Hello and welcome to Food and Climate, or Mat och Klimat in Swedish. Today the subject is direct air capture, and we have here three people who work with this in different capacities. And first, I would like that you present yourself and what your roles are. First to Shareq. Who are you?
So hi, I'm Shareq Mohd Nazir. I'm an assistant professor at the Department of Chemical Engineering at KTH, Royal Institute of Technology. My area of research is around CO2 capture and utilization and hydrogen production. So these are the main two themes of my research here at KTH. Within this, last year we received funding from the Swedish Energy Agency on a project that focuses on achieving energy efficient negative emissions from agriculture and farming sector, where we are trying to focus on removing greenhouse gases from air, which is closer to agriculture and farming sector. And when we say greenhouse gases, we are focusing on three greenhouse gases, which is methane, nitrous oxide, and CO2. So there has been a thrust on removing CO2 from air, but less on methane and nitrous oxide, but we're trying to combine removing these three greenhouse gases in one single system. So that's the project about. And we are collaborating with the Swedish University of Agricultural Sciences and also Uppsala University in this project.
Okay, very interesting. Just to repeat, did you say carbon dioxide, methane, and laughing gas?
Yes.
Yes.
Nitrous oxide, yeah.
Yes, nitrous oxide. Okay, and Finn Eriksson, who are you?
I'm one of the founders of the Nordic DAC Group, and we're building a digital platform for negative emission, that carbon removal from direct air capture technology and storage, so you create negative emissions.
And Peter?
Yes, Peter Magnusson, a co-founder and partner in Nordic DAC Group, primarily working with business development and sales.
Okay, just to say something about the company, or is it a project? Can you just say a few more words about what it is and in what stage you are, to give a context?
Yeah, we are a new startup, 2020 in January, and we're building up an ecosystem both with academics and prospecting building plants in Scandinavia and the Nordic countries.
Okay, very interesting indeed. So my first question to Shareq, first of all, is why is this technology, DAC, direct air capture, interesting and important?
So first of all, I can define what direct air capture is. Direct air capture is an artificial method to remove CO2 from air, where you pass air which is having CO2 around 400 to 480 ppm. That's what the CO2 levels are in air, and you pass this air over certain chemicals that selectively either capture or remove CO2. So they are, and then allowing all the other molecules to pass through it. So that's how you capture CO2, and then you regenerate this chemicals by providing heat, and so what you get is basically air without CO2, and you also get a concentrated stream of CO2 from the system. So it's an artificial way of removing CO2 from air.
So when you have removed the carbon dioxide from the air, what do you do with it?
So this carbon dioxide that is removed from air, this could be concentrated for it could be collected for storage, for permanent storage, or it could be utilized to produce other chemicals, useful chemicals, I would say. And this could be methanol, this could be any other chemicals that contain the carbon element.
So you could say that it's possible to actually use the CO2 for purposes. You don't have to necessarily store it in the ground.
Yes and no, I would say. It depends, because if you want to permanently remove CO2, then we need to store it or put it in the form that can stay in the atmosphere, or it could be permanently stored in some form for a very long period of time. But if you're trying to say that we want to convert the CO2 back into some fuel that is readily used, again, it emits back the CO2 to atmospheres. Then we are not doing justice to direct air capture, I would say.
Okay, and the question of importance of this technology. Why is it important?
So there are a few things that we need to understand, and that is we have CO2 capture systems for point sources. Then people are speaking about, if you want deep reductions in CO2 that is present in the atmosphere, and also if you want to accelerate our efforts to achieving net zero and then going beyond net zero to achieve negative emissions, I think direct air capture is going to play an important role in those scenarios. And what we already see is that this carbon removal technologies or carbon removal methods will play an important role in also not allowing a shoot in CO2 emissions before it starts reducing in achieving the targets which are set for 2050, 2070, and then 2100. So if you want deep reductions, I mean, this is one way to do it.
Okay.
And again, sorry to interrupt.
Continue.
Again,
Yes, continue.
There are natural ways of removing carbon dioxide from the atmosphere, and then this is an artificial way of removing carbon dioxide from the atmosphere. If you're speaking of natural method of removing carbon dioxide from atmosphere, then it is afforestation, which is a method. But then the land requirement for that to remove 1 ton of CO2 is very huge compared to the land requirement for a direct air capture system to remove the similar amount of CO2. So it can give you numbers. It could take between 0.4 to 25 kilometers square land area requirement for direct air capture to capture 1 million tons of CO2 per year. But if you compare it with the afforestation method, then that would require nearly 800 to 900 kilometers square for 1 million ton of CO2 per year. So these are the scales that we're speaking of.
And what we're talking about time, how fast can you actually, when the technology works as it's supposed to, how quick can you take it from the air?
It can be readily taken. I mean, CO2 can be readily taken out from the atmosphere as soon as you place the technology in. So it's very quick, even compared to, as I said, I mean, it again depends. So if you're taking 1 year perspective, then it depends on the area that you need to set up this technology. So if you have more number of units, so you're occupying more area, and then you're capturing more CO2, it's very similar to planting trees again. So you need to plant trees for 800 kilometers square to capture 1 million tons of CO2 in a year. Whereas here you just have to plant 0.4 to 20 kilometers square of DAC systems.
And when we talk about suck oxygen, no CO2 from the air with trees, the natural way, what time frame do we have? 20, 30, 40, 50 years?
I mean, that's a very long-term investment, I would say. I'm not saying we don't need it. I'm just saying that both complement each other. Both should be done parallelly. Yeah.
So we can say that the natural way with trees is something we really have to do as much as possible, but we also need technologies like this one to later on, from now on and forward, to decrease the level of CO2 in the air.
Yeah, absolutely. We need both, I would say. We need the natural way and the artificial way.
Yes, of course. Does Finn want to add something to this?
The main argument for this direct air capture is we have storage for thousands of years, and when you have forestry in the biosphere, nature-based solutions, you have shorter carbon cycles. So it's very important to take care of the biosphere, but also add these engineering solutions.
Okay.
We can have a permanence.
Yes. What kind of examples do we have in the world that you can describe? 2 or 3 that actually doing this right now?
I think there are two companies that have taken the lead, I would say. One is Climeworks from Switzerland, and the other is Carbon Engineering from Canada, if I'm correct. Yeah. And I think Climeworks right now has 16 operational units for direct air capture that are capturing nearly 2,000 tons per year of CO2. Whereas the Carbon Engineering, I think, has a pilot plant right now, but they are considering building a 1 million ton capture unit in the future. So these are the two companies, and then they have two different technologies, because Climeworks works with a low temperature technology, whereas Carbon Engineering is working with high temperature technology.
So the next question is, how big is the potential on a global scale for this technology? How much CO2 can be captured, and how big of a solution can it be?
Yeah, so I think for this we can refer to the IPCC 1.5 degree report, and clearly says that if you want limited or no overshoot to achieve the net zero targets, we need to remove in the order of 100 to 1,000 gigaton of CO2 in the 21st century. And just speaking of removal, so it's carbon dioxide removal, and then there are different methods to remove CO2. One method is bioenergy, carbon dioxide capture and storage. The other is afforestation, as we spoke about. And of course, direct air capture is another method to remove CO2 from atmosphere directly. So when we speak about 100 to 1,000 gigaton CO2 in the 21st century, it's a very huge amount. So all these methods need to go alongside each other to achieve these targets.
Okay. And the United Nations are really counting on these kind of technologies, aren't they?
Well, I hope so, yes.
Because to be able to suck up CO2, you need to be quite fast. Because if you plant trees now, which is so important, you will suck up the oxygen in 30 years or something like that. But if you have this technology on a big scale, you can suck up in the next 5 or 10 years, which is we don't have so much time, actually.
Absolutely. I mean, artificial methods, I think that they're really quick.
What is the goal for Nordic DAC Group? What are you aiming for going forward?
Yeah, we have big ambition to initiate and build out the DAC plants in the Nordics, and simultaneously build a digital platform to make it easy for big companies and small mid-sized business to buy a negative emission through this direct air capture technology.
Yes, and if we take in the research landscape, the development of the lowering of costs and support from European Union and for other investors, what do you see in front of you the next 5 to 10 years?
I think I can take it in steps. I think I can first speak about Sweden, because last year we were lucky to have 2 projects funded from the Swedish Energy Agency in this area, one with Chalmers and the Nordic DAC Group, the other, at KTH, along with the Swedish University of Agricultural Sciences and Uppsala University, and where both the projects focus mainly on removing the carbon from the atmosphere. So I think in Sweden we have started researching upon this topic, and I think we are going ahead with our efforts in this area. When we speak of EU, we can already see the Horizon Europe work program, and in that there are targeted calls in this area that are focusing on CO2 capture from air and utilization of that CO2, as well as removal of non-CO2 greenhouse gases coming from natural sources. So we are going to put in efforts to apply for projects in these particular calls, and as well as at a global scale, we also see that there are competitions like the X Prize competition that focuses on developing carbon removal technologies, and then we have prominent people like Bill Gates putting in a lot of funding in carbon removal technologies. So there is a lot of momentum in this area. If we just speak about research activities, we are mainly focusing on materials and processes. So our main focus is in developing materials and processes that can lower down the costs of direct air capture in the future.
Okay, fascinating. Finn?
Yeah, I can add to the momentum for the voluntary carbon market. It's a growing acceptance for pre-purchase agreements to support the technology development and allocate funds to build DAC plants. And also we see new corporations and business models like in the fashion industry and textile industry. There are competitors cooperating around mapping out the carbon footprint and so on. So it's new business models. And also we meeting lots of big Nordic industrial companies that try to build a purchase club for these initiatives in Sweden and the Nordics.
Okay, so to summary up this, we can say that to be able to reach the Paris Agreement, we need all kinds of technologies to take greenhouse gases from the atmosphere. This DAC there's no competition with planting trees and other plants. On the contrary, we need to go 100% with all these kind of technologies, right?
Absolutely.
Correct.
So thank you so much for this interesting interview. And we will come back to you both in article and interview later on to follow this subject. So interesting. And so thank you, Finn, Peter, and Shareq.
Thank you, Stefan.
Thank you.